Welcome to another edition in our CSEC exam past paper questions and solutions. Now, this question was taken from the May 2011 and it's question 5B on that paper. And it's a typically trigonometry and measurements question combined. Okay, so let's quickly get into it. Now, the diagram below, not drawn to scale, shows triangle PQR, which represents the cross section of a roof. Now QS is perpendicular to PSR, so this line here, QS, this vertical line here, QS, they are saying it is perpendicular to PSR, this horizontal line at the base. Now, since they have stated that it's perpendicular, we would have known that when a vertical or line meets a horizontal line, it forms a right angle, and that's what the word perpendicular mean. Perpendicular mean it meets at a right angle. So obviously triangle PQS is a right angle triangle, and since we're on it, we could just look at the fact that since angles on a straight line, we should know sum to 180. If this here is 90, then over here also must be 90. Okay, so here we have two right angle triangles combined. Okay, so the triangle QSR is also a right angle triangle. Just wanted to make note of that quickly. Now let's move on. PQ is equal to 12.6 meters, and that's this distance P up top here down to Q here at the base. And they're saying QR is equal to 8.4 meters, and the angle at P, which is angle QPR is equal to 15 degrees. Sorry, I forgot my degree symbol, so let me just drop it in quickly. This should be 15 degrees. Okay, now good. Having said that, here they are asking us now to using the dimensions, and let me just pull up this a bit. You could always pause the video and read the question a bit more careful. Okay, let me just pull up this and get into it quickly. Now here they are saying to us now that using the dimensions shown on the diagram, calculate correct to three significant figures. Number one, the length of QS, which is 2 marks. Part 2, the measurement of the angle RQS, which is 3 marks. Part 3, the area of PQR, which is 3 marks. Okay. Now here they're asking us to find QS. If you notice, QS is the perpendicular height, given the fact that we have established before that PQS is a right angle triangle. Since the angle at P measures 15 degrees, then we could use the trigonometrical ratios or trig ratios to find this height here, this perpendicular height. So quickly, I could say then, since they have given us the angle at P, I'm going to position. So you could always draw a little man like what I'm drawing, and let's say you're standing at that angle and you are identifying the side that is across from the angle. Now the side that is across from the angle is called the opposite side. Okay, and I put OPP for opposite. Now since this is a right angle triangle, as we have already established, the side that is across from the right angle triangle is called the hypothenuse. So I'll say hype for short. Now basically we were given the hypothenuse. If you notice, the dimensions of the hypothenuse 12.6, and we were asked to find the side that is opposite to the angle given. Now opposite and the hypothenuse would suggest that we would have to use the sine ratio. So we could say the sine of theta is equal to the opposite, OPP for short, for opposite, over HYP, which is the hypothenuse. Now, by substitution, theta represents the angle. Since the angle is 15 degrees, I could say the sine of 15 degrees. Sine 15 degrees must be equal to the opposite, which is QS. We don't know that. QS over the hypothenuse, which is 12.6. Okay. Now, we could, this is QS. So let me put that. Now, we're trying to make QS the subject. So since we have a fraction here, we could always turn sine 15 into a fraction, and we could just simply cross multiply. Okay, so we could say 1 times QS would give us QS, and that must be equal to 12.6 times the sine of 15. So I could say 12.6. Let me put that in bracket because I'm multiplying, and I'm multiplying that by the sine of 15 degrees. Okay, so we could quickly pull out our calculator, and here's our calculator. To find QS now, it's simply, I could find the sine, since multiplication is commutative, it doesn't matter the order. I could find the sine of 15, so I can press sine 15 is equal to, oops, well, this calculator is a bit different. Obviously, I'm going to have to press 15 first, the number first, and then sine. So it depends on the type of calculator that you have working with. Okay, so the sine of 15 is 0.2588, and if you notice, that's an irrational number, and I'm just going to multiply that number by 12.6. okay, and that is equal to, and here I have my 3.261. However, this was a very important note here. If you notice right here, they said that we should write our answers to 3 significant figures. So let's pull up back that digit. Now here we had 3.2611, and I'm just going to write out all of that. 3QS is equal to 3.2611, and I wrote that down up to 4 dp. Now they said they want it to 3 significant figures, and this is very important. As I've said, 3 significant figures. So to 3 sig fig, we would have gotten, let me just change my color, we would have gotten QS is equal to, this is the 3 is the first sig fig, this is the second, and 6 here would be the third significant figure. So my answer would be 3.26, and that's my answer. Okay, and it's that easy, guys. Now in the next video we'll work out part 2 and part 3. So stay tuned. Bye bye.